Hi, in the last video I did a review of this UNI-T MSO3054X quad-channel 500 MHz bandwidth 5 gig samples per second sampling rate mixed signal oscilloscope. And in today's video I will do a teardown and take a look to see if we can spot any hardware differences between the MSO3054X and the MSO2304X, which I reviewed a while back. After all, besides the enhanced bandwidth and the onboard sampling memory in the 3000X series compared to the 2000X series, the other capabilities are quite similar. Also, as you have seen in my teardown video of the MSO2304X, we have to pretty much disassemble everything for us to review the main FPGA due to how the heatsink is mounted, and to get to it, everything had to come out first. For the MSO3054X, I suspect it would be more or less the same. And I just removed all the 10 screws that is holding the back case together. You can see these. These are the machine screws. These are very high quality ones. So from a glance, everything looks the same as what's in the 2304X, but of course you can see here we have this Wi-Fi antenna. And that's because we have a Wi-Fi module inside this 3054X. I need to remember to be very careful when removing the case, as I certainly don't want to break the connector here. This time around it was a lot quicker to take everything apart, as the process is exactly the same as disassembling the MSO2304X. Of course, I was extra careful with the flat flex cable for the display, as I didn't want to turn this into another repair video. And that was what happened when I was trying to reassemble the MSO2304X after the teardown. If you watched that video, you will know what I'm talking about. Anyway, I will link the repair video up here if you are interested. And here we have the main board. I have already removed all the shooting cans and also the heatsinks on these chips. At a glance, I didn't notice anything that is different from the main board of the MSO2304X, except for the Wi-Fi module here. And that's pretty much what I expected. By the way, I will leave a link to the teardown video of the MSO2304X in the card up there. In this video, I probably won't spend as much time as the board layout and most of the components seem to be identical. Here are a couple of pictures side by side. And you can see the only difference on this side appears to be the Wi-Fi module right here. But I do want to check out whether there's any difference I can spot in the input sections, as the MSO3054X has much higher bandwidth compared to the MSO2304X. I just zoomed in a little bit, and by the way, these two channels are for the function generator. They are identical to the 2000X series. They're driven by this ADC9122, which is a dual-channel 16-bit DAC. The signal processing for the function generator is done in this Spartan 6 FPGA. And the part number is XC6SLX16, which is exactly the same one used in the MSO2304X. And by the way, between the function generator and the input channels, here you can see we have this section of circuitry, and that I believe is controlling the probe compensation signal, as the output frequency of the square waves coming out from the probe compensation testing section can be adjusted independently for each of the channels. Alright, back to the input channel. Let me put a picture of one of the input channels from the MSO2304X up here, and let's see if we can spot any difference. Now it appears there's only one difference I could spot between the front end sections in these two oscilloscopes. In the MSO3054X, the chip I circled here is marked as TI41-4HV, whereas the chip at the same spot in the MSO2304X is marked as TI38-4HV. By the way, we're currently looking at the circuitry of channel 4, and all the other components, including the silk screens and values, are exactly the same. UNI-T used the same LMH6518 900 MHz digitally controlled variable gain amplifier chip, and also used the same BUF802 high-speed op-amp. The BUF802 has a gain bandwidth of 3.1 GHz. So it appears that perhaps the 8-pin chip TI41 maybe is the key here, but I can't find any information on the TI41 or TI38. If you know what these 8-pin chips are, please let me know in the comment section below. So the differences of the front-end components between the MSO2304X and MSO3054X are minimal, and the only difference I could spot is that single chip. The ADC chips used here are exactly the same as in the MSO2304X. Two ADC chips are used to form the 5 gig samples per second sampling rate for a single channel, and of course, the sampling rate would drop to 2.5 gig samples per second if both channels are enabled. And that applies to either channel 1 or 2, or channel 3 or 4. Altogether, we have 4 of these ADC08D1000 chips. As mentioned in my MSO2304X teardown video, each of the ADC 0AD1000 contains 2 ADCs, and these ADCs operate at up to 1.3 gig samples per second. So to achieve the 5 gig samples per second sampling rate, the samples from 4 ADCs in these 2 chips are actually interleaved. By this design, channel 1 and 2 are independent from channel 3 and 4. So if you need the full 5 gig samples per second sampling rate when 2 channels are enabled, you can choose one channel from channel 1 and channel 2 and then another channel from channel 3 and channel 4. Between these 4 ADCs, this chip here is marked as 7044, which is an HMC 7044. I mistakenly called it a clock synthesizer in my 2304X teardown video. This is actually not a clock synthesizer, but rather a jitter attenuator. Its job is to generate low phase noise clock references for these interleaved ADCs. Down here we have the main FPGA. And like what I had expected, it's the same Xilinx Kintex 7 XC7K325T, which is exactly the same used in the MSO2304X. And these are the sample memory chips for the acquisition. What surprised me though is that the sample memories on this 3054X board is exactly the same as was on the 2304X. From the specifications, the 3054X has deeper memory depth compared to the 3304X. So I would have assumed that the memory chips here would be of higher capacities. So perhaps the memory depth is just limited in the firmware in the 2304X and not limited by the hardware. If you remember, the MSO3054X actually run a lot quieter than the MSO2304X, so I thought they might be using a different cooling fan. But after I remove the cooling fan, you can see that it actually is exactly the same model. It is the RCD4010H, and this model is used in the MSO2304X as well. So I'm actually a little bit surprised. This fan is a lot quieter in this scope compared to the MSO2304X. Let me shift it to the right a little bit. And here you can see the application processor used is also identical to the one used in the MSO2304X. It's a Rockchip 3568 quad-core ARM processor. The memory chips here are also identical. By the way, all these teardown pictures of the MSO3054X and MSO2304X are on my website, and I will provide links in the video description below so you can take a look and compare at your own leisure. And move right a little bit. And here perhaps is the only other difference on the main board. The module here is responsible for Wi-Fi, and it was absent on the MSO2304X because that scope does not support Wi-Fi and only support Ethernet connection. You can also see that we also have a MA3232 RS232 line driver up here, and I'm assuming that it's working in conjunction with this Wi-Fi module. Now, interestingly, the MSO2304X also has the MA3232 in place, but just not with the Wi-Fi module. Now, I just realized that the Wi-Fi module actually has 2 of these antenna connectors. Now, I actually don't remember which one the antenna was connected to. I guess I'll have to figure that out when I reassemble the oscilloscope. I guess I wasn't expecting 2 antenna connectors, but anyway. Up here on the left, you can see we have 4 of these ADCMP562 high-speed dual comparator chips. There are altogether 8 of these, 4 on this side and 4 on the other side of the board, which we'll take a look shortly. These are for the 16 digital channels. Now let me flip it over and take a look at the other side. Again, on this side, everything we see here looks exactly the same as what we saw in the MSO2304X, and up here, these are the 4 additional ADCMP562s. Towards the center of the board, you can see that is our TCXO temperature compensated oscillator. And let me just slide the board around, you can see it in close up. And these are the decoupling capacitors for the FPGA, and here are more decoupling capacitors for the CPU. And these are the comparator chips, and there's some solid relays on the input channels, and that's about it. The rotary encoder board is also the same, and so is the keypad board. The board is actually marked as, you can see here, MSO3000X. So at first I thought they might have designed a different board for the 3000X series. But I went back and checked the keypad board in the MSO2304X, and it actually has the same silkscreen. I guess I just didn't notice that back then. So these are identical. So let me flip them over and you can see the other side. And there's nothing on the encoder side. And on this board, of course, we have a microcontroller. And by the way, these headers are actually made it onto the encoder board like this. You can see that. That's how it was assembled. And here another difference is this BNC board. Because the MSO2304X does not support active probes, that board was just serving as a ground plane. But you can see here, this board actually has a microcontroller on it. And that's because the MSO3054X also supports probe interface for active probes. And here is the other side. You can see here we have the contacts for active probes here. And just for completeness, I also removed the cover of the power supply. Of course, I wasn't expecting to see any difference. And here you can see that the power supply used is exactly the same as what's used in the MSO2304X. And here you are looking at the front panel, and underneath that's the LCD, and here are the interface connectors. This one is the flat flex for the LCD display, and here is for the touchscreen. Of course, you can see that that was the connector that I managed to dislodge on the MSO2304X. I wish the cable here is a little bit longer, and that will make reassembly a lot easier. I have to say the build quality is excellent for both the MSO2000X and the MSO3000X series. There is not a single botch I could spot, and everything was meticulously put together. All components are top-notch ones. The frames are well made, all edges are rounded, and all screw holes line up precisely. Even the shooting cans are very well designed. And how everything comes together is well thought out. Alright, I hope you enjoyed this teardown video, and remember to check out my teardown video of the MSO2304X as well, since I explained at greater details in that video. If you liked the video, please remember to give it a big thumbs up, and don't forget to subscribe to the channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.